All right, good morning. I will definitely keep us on schedule. I'll keep this short and have a little more time this morning for some of the other talks. So you have a handout of this schedule because it was going to be too small to see. I'll just go through the highlights of this, so look at it along with what your handout is. This is starting with workshop 1 that we had in March. We're now, we've been addressing the data needs as we went along here. We're now at workshop 2 in October, and we'll be developing right after this the weights that will go with our updated ground motion logic tree. What you will see is the structure of the next version of the logic tree that we're anticipating, but it'll be based on what we see today. We'll develop that model shortly, and then that will be available for some updated sensitivity calculations. Following this workshop, the next 4 months, we're going to be focusing on doing our evaluations of these alternative models. What are their strengths and weaknesses? How do we start to assign weights to the alternative approaches? And we'll build from there our next ground motion logic tree here in version 2, just before in February next year, and we'll then be holding our workshop 3 next March. So in that particular workshop, we will then be coming and presenting what is our interpretation and our draft model in terms of the structure of the logic tree and the weights, and providing the basis for that, that work. Following that, we'll expect to be getting feedback and input from many of you who will be here for that workshop as well. And we'll be revising our model, and then we'll build our version 3 ground motion logic tree, and then prepare as well a draft report that at least can be reviewed for the structure of the technical results. That report will be reviewed by our review panel. So they have a couple of months to do that review, and based on that, we will then be making a revision to that model to address their technical comments and building what is going to be our final ground motion logic tree here in, we've got it in September, but it's supposed to be done beginning or end of August. We'll have that model completed. That's the model that will then be available to use in the hazard calculations and moving forward. During that time as well, we're starting to prepare all of the documentation for the report. Following that, there will be a report prepared, and our review panel will have opportunity to review that, primarily for documentation adequacy at that point, and then we'll finalize the report, and it will be submitted to the NRC in March of 2015. So along the way, our review panel provides us written comments after each of these workshops, and where they provide us probably most of their key technical input's going to be in their evaluation of our draft model. That's a complete model with the technical basis written in there at that time. So the project objectives, what are we trying to do in a really broad sense here? So we are making ground motion models or ground motion characterization for a reference rock site condition. So that site condition will be the same for Palo Verde and for Diablo Canyon. And then both of those sites will be adjusting off of that reference rock hazard study or hazard to give to account for the site-specific effects. So as Corolla mentioned, we're after capturing center, body, and range to get the epistemic uncertainty of our technically defensible interpretations. For us, it has 2 parts. There's a median and there's a standard deviation. Our goal of this study is to be mean-centered. We don't want to be biased high or low on any of the parameters. The only time we would probably be choosing a conservative approach is if a parameter did not matter or had a very small effect on the hazard, and we simply could choose a conservative number and then simplify our logic tree and move forward there. But in general, we're trying to build a mean-centered model that captures the uncertainties as well. The model has to be applicable to all of these relevant sources that the source characterization team can come up with. So that's our difficulty here, because we're not sure what are all the bells and whistles that they might come up with in their source characterization, but we have to be sure that the model works for anything that they are building in their models. As well, we have to address an interface between how the site response is going to be done at the two studies and how it fits with our reference rock site condition. And so for that, we prepared a white paper to describe this. This is one of the requests from the last workshop on how these two pieces will fit together. Pieces that are outside, or topics of ground motion that are outside of what our study is here, are two parts. One is the site response. So that is done separately by each of the nuclear power plants, and they're responsible for those calculations. And the second part here is the time series part. So we had some discussion of this last time, how are we specifying the input motions. That will be the issue of selecting representative time series that will be used later on for input to fragility analyses and studies that are used in the seismic probabilistic risk assessment. So these two things are outside of our scope, although what we will be producing will influence how those two things are done. Okay, so last time in March we met and we went through our data needs workshop. What we're trying to do at that workshop is identify work that could be done in the schedule that's available that would have a good chance of reducing our uncertainty in our ground motion model. So we had a series of topics that were addressed. Then our issue is to prioritize those on looking at two things: what has the largest impacts on our hazard moving forward, and how long does it take to complete the studies. We have a strict schedule, so we can't extend the time period. And so we were looking at both of those in developing our list. Some tasks that were developed may not be completed in the time that's allowed, and our approach to dealing with that is to then broaden our uncertainty. If we weren't able to do the work that would reduce the uncertainty, we'll stick with broad uncertainty bounds and move forward. So the data, I tried to organize these data needs. You have a separate table that has all of them listed on there, and they're organized in these 9 categories of normal faulting factors, near fault effects, hanging wall models and effects, how we handle multi-fault ruptures, ground motion data in Arizona and how that may differ from our California models, kappa, path effects, trying to see if there's something specific from a particular source to a site from an important controlling source. Single station sigma, so how are we going to characterize the standard deviations, and then other constraints from fragile geologic features. And these are just a number of tasks that fall into those categories. So I'm going to run through them all. These should be familiar to you if you were here in March. This should all at least start to sound like something you've heard before. So, normal faulting factors. This is important for Palo Verde. This isn't a Diablo Canyon problem, but for Palo Verde normal faults, as you'll see, will have an important contribution to the hazard. That's a part of the ground motion model that is not nearly as well constrained as the strike slip or the reverse parts due to a much smaller data set available for normal faulting earthquakes in terms of ground motion. So the topics that were identified to try to look at those factors were, one, looking at the Fukushima Hamadori earthquake. This is a large earthquake in Japan following the Tohoku earthquake. That data set is, status of that is being compiled and will be part of the peer data set moving forward. The second part that we're looking at, and I should say, our goal when I was talking about the schedule, all of this work has to be done, our data collection and data needs have to be addressed by February. Anything after that will be too late for us to bring along. So that's going to be our end date for bringing on any new topics. As I said, if one of these is unable to be completed by February, then we will simply broaden the uncertainty to address that topic and go forward. Another topic that came up was to look at the data from the Wells, Nevada earthquake. This affects us for normal faulting factors. This also was data that could have been used to look at directivity effects from normal events. We haven't started that review yet, but we're planning to describe that in workshop 3. The third one here is reviewing Bindi's data for normal faults. So the Bindi's model is an Italian model that has a greater number of normal faulting earthquakes than what we have in our data sets. And so we want to see if this gives a better constraint on what the normal faulting factor is, and that has been reviewed. We've reviewed as well the source data for Japanese events for style of faulting. Part of this is to see what's in that. So Adrian Rodriguez-Merrick has been reviewing some of the Japanese data, and we're expecting to have a summary of the Japanese style of faulting data for workshop 3. The next big topic was normal fault effects. So, near fault effects. So there's two parts to this. One is what happens as we scale close into large magnitude events. The ground motion models that were discussed last time all had either full saturation or undersaturation of the ground motion. That meant as you are at short distances and the ground motion, the magnitude increases from 6 to 7 to 8, the median ground motion does not decrease. If it goes down, we call that oversaturation. But we want to see if this is seen in the finite fault simulations, because there are indications that that type of behavior may be correct. That's one of the finite fault simulation problems that we're planning in our second set of simulations that will be done in workshop 3. Today you'll hear about the first sets of simulations being done, or the results of the first sets of simulations and feedback of those, addressing mainly the hanging wall effects that we'll get to and complex ruptures. So the other part then is how do we capture directivity in our near fault effects? Some of the ground motion models, some being one, the Cho and Young's model has directivity built into it. The other models don't have it in there, as it's been a pretty difficult thing to do. And so the question we're addressing is does our standard deviation in our ground motion models capture directivity? Is it adequate? Or do we need to broaden that standard deviation out when we're close into larger earthquakes? So that work is in progress. Jenny Watson-Lamprey has been working on this for a while, and we have some initial candidate models that will be presented on the third day. The next topic is the static offset, so we call fling. That is the impact of that being removed from the ground motion data as part of the standard processing. How does it affect us in sort of 3 to 5 second period range? That work's complete. Ronnie Kamai had finished that up and his paper submitted, so that is done. The next topic was Jack Baker and his students have a different approach for modeling directivity, and here it's how should we use it? And it's been not trivial for us to fit that into the approaches that we're using. So Jack will be here and present us a suggestion on how to move forward, or at least capture the what is contained in that model in our current approaches. Hanging wall scaling was something we spent a lot of time on. This is a mainly Diablo Canyon effect, so we're close into several faults, and the hanging wall effect can be important. So one was to see, can we get additional data in the magnitude 5.5 to 6.5 range. This is the part of the model that's very poorly constrained in terms of how it should behave. Our numerical simulations that we used previously were for larger magnitudes mainly, and our empirical data were primarily for the larger magnitudes. The question is, could we find some Japanese data that would have recordings on both the hanging wall and the footwall? And if so, how do those compare to the scaling that's in the ground motion models currently? This again is not completed in terms of pulling these Japanese data together, as well as getting through all of the metadata, but we're planning to have this completed for that should be workshop number 3. The other part of this is in finding these earthquakes, we may not have the finite source information, which is really key. If we want to do hanging wall effects, we need to know what is the rupture dimension. So if there's some that look like good candidate sites, we will then do a source inversion for those to be able to get the dimensions out. That's the same thing, that type of thing we did on the NGA West 1 project for the Taiwan, the big magnitude 6 aftershocks, the 4 or 5 of those that were available. Then we're looking at running the finite fault simulations to look at how they behave in terms of predicting hanging wall effects going down to magnitude 5.5. So those runs have been done. I should say initial set complete, and we'll be talking about that at this workshop. And there's some interesting issues that start to come up as it becomes not simply the geometrical effect we've talked about in larger magnitudes, but maybe a little more complicated than that. The other part was running alternative models for the finite fault simulation for hanging wall effects. So for the NGA West 2 project, we used the Graves and Pitarka method to run a whole suite of cases to tell us give us some insight into how hanging wall effects should scale with magnitude and dip and distance and so forth. So now we have rerun those for magnitude 7 case for 2 alternative methods. So you can see how stable or robust those features are coming from the numerical simulation methods. And that will be presented by Jennifer. Next, multi-fault ruptures. So we have 2 types of multi-fault ruptures, and you'll hear this several times today. One is a rupture that changes dip or rake along strike. So it's not the same thing all along. We're not talking about bends of the fault, but we're talking about changes in rake and strike, rake and dip along strike. And we call that complex ruptures, just to keep the terminology straight. We also have a case where we might have overlapping ruptures, a main rupture going and then a splay coming out for that. And if your site is close to that splay, how is it influenced by now 2 ruptures happening potentially with ground motions interfering from one another? And we're calling now splay ruptures. So the topics that we're looking at is one, we had before looked at past ruptures that were complex ruptures, and trying to see how we could compare the empirical data set with what is being used for the more simplified description of the rupture that was used in developing the ground motion models. And some of that we found we had mixed or had the total offset, which was mixing post-main shock or pre-main shock surface rupturing or deformations, and so that's been removed from the data set, so we're not looking at that problem anymore. We've also gone back and reviewed empirically the empirical data set for multi-fault ruptures to see how does it compare, or what are the residuals look like from these cases. Are they fundamentally different? And looking at alternative methods for modeling this approach, or how do you deal with that? And that will be presented by Carola later in this workshop. Then we also looked at suites of finite fault simulations, so 2 sets, 1 set for complex ruptures, and those ruptures or simulations have been done. You'll see mainly the results of that at workshop 3, but we've also run sets for splay fault ruptures, so you'll see some of the simulation results from that, and initial results will be presented here by Katie Waddell. Then the last part, we're looking at also moving from the kinematic simulations to using dynamic simulations to help constrain the source properties of this splay fault. So if you're going to have a main fault rupture and then another rupture coming off to the side, what does that side rupture look like? Is it the same behavior as just a smaller earthquake, or is it different, and how do we piece all that together? So dynamic rupture models let us start to put that or answer that question. Julian Losos will be addressing that. This work has just begun. He's a new postdoc here at Berkeley, and he's getting started, and we'll mainly talk about the approaches and what the planned work is here. We want to get feedback as well as to if we've got the right plan for that topic. Arizona ground motions is another topic that our ground motion models had. Our data set that started out with probably 0 data. Is that right, Yusef, from Arizona? I think it was 0. And so we've now added the data that we could find from that. So the question really is, are these ground motion models we derive from worldwide data but dominated by California, Japan, and Taiwan, for example, are those applicable to Arizona? So part of this was looking at data. One was the density data from historical earthquakes, so we pulled that or got that report. We've also wanted to add in a couple of the VA hospital ground motions from Elmira Kukapa. We haven't done that yet, but we will get that pulled together before workshop 3. We've compiled and processed the local data for getting at Kappa, so local earthquakes in Arizona, so PEER has done that work. And also looking at Arizona ground motions from distant California earthquakes, in particular earthquakes that were already part of the NGA West 2 data set, but that had recordings in Arizona. And so those have been added and processed by PEER. So Kappa is another big topic for us, and this Kappa is an issue for both Arizona, for both Palo Verde and Diablo Canyon. You'll see there's more here in Arizona of issues that we're talking about. First, we were looking at what sites could we use to identify Kappa, so we picked 9 sites, I think, is that correct, that we're looking at, of not strong motion sites, but broadband sites. Then we got those sites and conducted the site characterization. So that work has been scheduled. Rob Kane out running SASW at those sites, so we'll have a shearwave profile scheduled for the end of October, November. So probably end of October, broadly envisioned as the end of into November. Getting Kappa estimates then for those Arizona stations. So Olga will be talking to you about first processing and looking at the Kappa for Arizona sites. There are some particular difficulties we have with the available data in trying to be able to resolve Kappa, but she'll talk about that for you. One other issue that came up was, can we use blasts to get at Kappa? And so some of this work had been looked at Reno, and we have not done the review of this yet. So this is still a pending task. If we can get at Kappa from the earthquakes, I think we will do that and not focus on the blast. If the earthquakes really are going to be a big problem for us, then we'll move back to seeing what we can pull out of the blast data. Kappa estimates then for Diablo Canyon. One of the issues we're looking at there was trying to measure Kappa from the small earthquakes recorded by the geophysical arrays. So there was a presentation last time of a suite of little earthquakes, magnitude 0.5 to 1, that happened to occur at the same time the onshore geophysical program was going on. And so we have a large data set of these little earthquakes, but it's a different frequency band and a whole other issue in terms of how do you get Kappa from that kind of information. And that is put off while we're dealing with Kappa in Arizona, but it will be discussed in workshop 3. Path effects, now we're making things sort of to the next level of complexity or regionalization beyond using a site effect and using single station sigma. You can look at trying to identify systematic and repeatable path effects. And are those captured can we see those differences in our model? So one part here was to start to use a series of 1D velocity models derived for Diablo Canyon based on the new seismic data that's available. That could then be put into the kinematic simulations and doing forward cases here. This work has not happened yet. We're really trying to see what our schedule is going to be for the simulations, and will we be able to incorporate other suites of velocity structures and with Green's functions, or if we're going to use generic ones at this time. What you'll see today in terms of the presentations are using sort of broadly generic California Green's functions, not trying to identify specific path effects. The question that we're going to get, another one is, though, are we missing something really important, fundamental in 3D effects that isn't captured when we're just doing our current models? So part of this is looking at Loma Prieta. There's been modeling done both with 3D and 2D effects, and I think 1D structure models. And this work is in progress. You'll see some discussion of what's going on at work today or during the workshop here. And we want to really decide how much we want to push these two pieces here moving forward. This may influence a little bit of, this one might influence a bit of what we do on the first one in terms of going that direction. The reason for this is this could be a large effort for us, and that would have to then, if we're doing that in our schedule, probably offset some of the other work or have to push it back. Then we're looking at regional data around Diablo Canyon for path effects. Most of our data that we've looked at were from the land side, where we had recordings from the San Simeon earthquake and the Parkfield earthquakes and the Deer Canyon earthquake at Diablo Canyon. But our main sources that control the hazard are offshore. And is there a real difference in the offshore wave propagation? And so I put here onshore, but this should be offshore paths. Sorry about that. And so we're looking for really new data. And so Marcia McLaren will talk about new instrumentation that's been installed, some offshore OBSs, and an additional seismic instrument installed at Diablo Canyon that we're trying to put to record as small of earthquakes as we can, given the noise there. And so she'll talk about what's available there. So this is really depending on new data coming in, and if we're going to have any little earthquakes offshore that will trigger these systems in the next 6 months. Finally, we're looking at what do you do with all of this stuff, and how do we get, if you're going to develop a single path model, then the standard deviation needs to be adjusted to also be a single path sigma model. So this is work that, we were using the data from the California earthquakes, basically from NGA West 2 results, to see what we see for, see what the single path sigma is. This is work by Manuela Villani, and I will describe that for her during this workshop. Single station sigma is so the standard deviation is a big factor for us as well. This only has one task, but it's a really important one. And that is getting at a single station sigma model based on California data using the NGA West 2 results. One of the key efforts in NGA West 2 was to extend the models down to small magnitudes. The purpose of that was to be able to get at a single station sigma model. So this is really taking advantage of that whole big effort to collect all this small magnitude data. You need to do that because to get enough recordings at a station, we have to go down to small magnitudes. We can't do it with just a large magnitude data set. So the database is greatly increased, and Linda Alatek will talk about the model that she's got so far, and this will be finalized for our development in the next couple of months. The last pieces are on the fragile geologic features. So we've been looking at that. One was evaluating those near Palo Verde, and there is really, that work is complete. There wasn't any promising features identified. At Diablo Canyon, we're also evaluating the fragile geologic features, and Mark Sterling, who's done this work in New Zealand quite a bit, and will show an evaluation that he's made of what's fragile geologic features are near Diablo Canyon and potential for them to constrain the hazard. So that work is in progress, but he'll show you what he's found today. And with that, that should have captured everything that we listed from workshop 1. If there's anything that you think we missed, you can let me know and we can add it in. Did that all sound familiar? A little bit? You should have each recognized at least one of those topics, right? So there's a whole lot of stuff going on here, and we're trying to pull it all together. That's why, well, we've made a lot of progress in the last 6 months. We still have a ways to go to get all of these topics done. Okay, am I on schedule? Pretty close? All right. Any questions? None. All right, we have about a half an hour at the end for a broader discussion.